Welcome back, everyone. We're going to be solving LeetCode 238, product of array except self. So we're given an integer array nums, and we want to return an array called answer such that the ith value is equal to the product of all the elements of nums except nums of I. They tell us the product of any prefix or suffix of nums is guaranteed to fit inside of a 32-bit integer, and they want us to write an algorithm that runs in O of n time and without using the division operator. And then we do have a follow-up question down here. They want us to solve the problem with O1 extra space complexity, where the output array does not count as the extra space for the space complexity analysis. So let's take a look at example 1. They give us an input array of 1, 2, 3, and 4, and our output should be 24, 12, 8, and 6. Right, so this first position, it should be 24, right, because 4 times 3 times 2 is 24. We move on to the second position. 4 times 3 times 1 is 12. Move on to the third position. 4 times 2 times 1 is 8. We move on to the last position. 3 times 2 times 1 is 6. So that's how we get our output array. But how can we do this without using the division operator? Well, we are going to have to use prefixes and postfixes to do this. So what we're going to do is we'll initialize an output array to all ones equal to the length of our input array. So our resulting output array is going to be equal to 1, 1, 1, and 1 initially, instead of 1, 2, 3, and 4. So we'll say res is going to be an array of ones equal to the length of nums. And like I said, we're going to be using prefixes and postfixes to solve this problem. We'll initially set them equal to 1. Now, to calculate the prefixes, right, we're expecting 1, 1, 2, and 6. Right? The prefix of 1 is nothing, right? There's nothing before it, so it should just be 1. Now, if we move on to 2, the prefix of 2, what's the value before it? It should be 1, right? So that's how we get 1 and 1. If we move on to 3, the prefix of 3 should be 2, right? And then if we move on to 4, the prefix should be 3 times 2, which is going to be equal to 6. That's how we get this 1, 1, 2, 6 output. So how are we going to calculate this? We are going to have an initial pointer set to 0 for our prefixes. So we'll say our prefix pointer is going to be set to 0. We're going to loop through this array, take this value in nums, multiply it by our prefix, take that value and set it equal to our, or put it inside of our resulting output array. So we will say while the length, not the length, we'll say while our prefix pointer is less than the length of nums, we are going to update that position within our resulting output array. So we'll say prefix pointer in our resulting output array should now be equal to whatever our prefix is, right? So the 0th position should be 1 initially because our prefix starts at 1. Now, after that, we have to update our prefix, and our prefix, in order to update it, we are going to take the prefix and multiply it by whatever position we're currently at. Instead of multiplying it by the res of the prefix pointer position, we are going to multiply it by the nums of our prefix pointer position, right? So 1 and 1. So 1 times 1 should give us 1. Now, after that, we need to update our prefix pointer. So we'll say prefix pointer is going to be updated by 1. So let's print out our resulting output array to see what we're working with now. We should get 1, 1, 2, and 6. And I spelled something wrong. Okay, here we go. Prefix pointer, pointer. Okay, let's retry this. Yep, so we get 1, 1, 2, and 6. Okay, perfect. Now, we need to do the same thing, but with the postfixes. So we are going to have a postfix pointer. So we'll say a postfix pointer is going to be equal to, instead of 0, right, we're going to go backwards. So we'll say it's going to be equal to the length of res minus 1. And we are going to loop through while our postfix pointer is greater than or equal to 0. So we'll say postfix pointer is greater than or equal to 0. Now we know we're going to eventually decrement this at the end of our loop. So we'll say postfix pointer minus equals 1 at the end. Now we need to update our resulting output, and then we also need to update our postfix value. So we are going to say our result at the postfix pointer position is going to be equal to the whatever our current value is. So if it's 6, we're going to take that and multiply it by our postfix. Right, so that should give us 6 times 1. That is going to give us a value of 6 in this position. Now we have to update our postfix. So we will say our postfix is now going to be equal to the multiplication of wherever we're at with our postfix pointer multiplied by the nums value of the postfix pointer. So instead of doing nums of prefix pointer, we're just going to do postfix. So that should give us 4 times 1. So now our postfix instead of 1 is going to be 4. So we updated this value. It's still 6. Perfect. Now we're going to take this value, multiply it by our postfix, which should now be 4 after this loop executes, and that is going to give us 8. See how we're incrementing our resulting output array? So after we do all this, we should get 24, 12, 8, and 6 as our output. So let's now return our resulting output array. Let's change this postfix back to 1. And just making sure I didn't spell anything wrong here. All right, we'll run this. And I still did postfix pointer, postfix. Postfix. Man, I am having trouble with spelling today. Postfix. Okay, so we can see we passed both test cases. Sorry for the spelling mistakes, right? It's a rough start to today. So let's, we know it works now, so let's submit. We'll see if it passes the test cases. And it does. Perfect. So that's how we can get or calculate the product of array except self, right? And we did do this in an O of n time complexity, right? Running this while loop is going to be O of n, and then running this while loop is also going to be O of n. O of n plus O of n just simplifies to O of n. And then the space complexity, right? We only used this resulting output array. And for this problem, they did tell us that the output array does not count as extra space. So we did do it in O of 1. If they didn't tell us that the output array does not count as extra space, right, I would still ask the interviewer if it would count as extra space. Otherwise, you could say it depends on the length of our resulting array here. All right, that'll do it for LeetCode 238.